Ready? All right, now we're going to work with the hydroxide ion, the 3 column. We're getting to the halfway point on this. Hooray. All right, hydroxides are going to be important because they react with acids. These is going to be the complement to an acid, which is a base. So we're going to move through those pretty quickly. So we'll start out 1 to 1 again. They're going to cancel out. We're going to have sodium hydroxide. It's 1 to 1, so we just go NaOH. This is what I call my son Noah. This is sodium hydroxide, commonly called lye. Then we have a weaker base, which is going to be ammonium hydroxide. We have 1 ammonium ion and 1 hydroxide ion. They cancel out, so you just write it out as NH4OH. It's ammonium hydroxide. Then we come to potassium hydroxide. Once again, 1 to 1. Super easy. KOH. My student's name, Ko. This is why I think of you every single time I see your name. Okay. Then we move on to calcium hydroxide. We have a 2 and a 1, so we'll need 2 hydroxide ions, so we'll need parentheses on the hydroxide. So you've got Ca, we only need 1 of those, so we don't have to do anything to that. Then OH2. Likewise with magnesium hydroxide. We bring down our 2 right there. We have Mg. We only need 1 of those. And then our parentheses, OH2. And that's magnesium hydroxide. I'll show you how to make that actually in class when we get a chance in our when I have my fume hood working. Zinc hydroxide, same thing again as we've done on the last few of these. We're going to need 2 hydroxide ions for every 1 zinc ion. ZnOH2. Okay. Up to the top, now we get to the weird one, the iron 3. So I'll need 3 hydroxide ions in this case. So we only need 1 iron oxide, so our 1 iron ion, excuse me. And then we go OH, then we put a subscript of 3 down there. Okay. Likewise with aluminum hydroxide, this was used in an antacid called Gaviscon. An old antacid, aluminum hydroxide for people who had acidic stomachs and stuff like that, way back a while ago. So aluminum, we only need 1, so we just have Al right there. Got our 1 right there. Then we have our parentheses. We need 3 OH, 3 hydroxide ions, so there's aluminum hydroxide. Cobalt hydroxide, once again, be careful with your capital and your lowercase o's on that. We need 1 cobalt, so 1 cobalt. And then we'll need 3 hydroxide ions. So we've got those nice and neat like that. Iron 2, this one will only need 2 hydroxide ions. So we'll go ahead and write this out. Fe, we only need 1 of those. So we will need 2 hydroxide ions, OH2. Then we have HOH, hydrogen hydroxide, or as you were looking, what did we also call that? We had dihydrogen oxide, stuff like that. So here we go. They're going to cancel out, and you end up with HOH, which we can also write as H2O. This would be the result of an acid-base reaction where they neutralize. And then the last one, we have tin hydroxide. So we need 4 hydroxide ions for every 1 tin ion. So SnOH4.